Welcome to lesson 12.4. Today we're going to talk about the zeros of a quadratic. So zeros are like the most important part of a quadratic function. So your aim today is that you can determine the zeros of a quadratic function by factoring and then using something called the zero product law. So we're going to work around zeros today. Something I want to say before we get going though is that zeros have many different names. They're also called roots, they're called x-intercepts, and they're also called solutions. Okay, all of these four things mean the same thing. It's all the place where the graph touches the y-axis, and the x-axis, sorry. So let's read this paragraph first. The x locations on any function where the output y coordinate is equal to 0 are known, not surprisingly, as the zeros. And we've talked about this many times. These are amazingly important in applied settings, like word problems. When they are rational numbers, they can be found using a factoring technique. So rational numbers meaning like a fraction or an integer, right? If it's a decimal or something we have to, calculate, then we can't find it using this technique. But this works for a lot of problems. So let's take a look at the idea in exercise 1. It's going to show you what they mean by this. So here's the quadratic function, y equals x squared minus 2x minus 3. So this is the function that we're working with right here. And it's graphed right here on the graph. Notice that you have a y-intercept of -3 and a y-intercept right here of -3. So that matches up. And the first problem is going to have us just figure out where the zeros are. So what are the zeros of the function? Write their x values and circle them on the graph. So I'm going to go to my graph. Well, here's 1, 0 at that point right there, and there's the other one. Okay? It says write their x values. So one of the zeros is x equals -1, and the other 0 is x equals +3. Right? This is the point 3, 0, and this is the point -1, 0. Okay? The second step says verify that the positive 0 is correct by showing that y equals 0. So what that's saying is, okay, so here's our positive, here's x equals 3. So I'm going to say, all right, let's let x equals 3. So I'm going to say y equals, I'm going to plug 3 in. 3 squared minus 2 times 3 minus 3. So we're just double checking that if I plug 3 in here, I should get y equal to 0. So let's simplify. Y equals 3 squared is 9, minus 2 times 3 is 6, minus 3. PEMDAS says I go left to right, so 9 minus 6 is 3, and 3 minus 3 is 0. So I did actually end up getting the correct answer. It was just doing a check, right? So now we're going to talk about how we could find these two factors without using a graph. So let's take a look at the equation. Here's the expression x squared minus 2x minus 3. This direction says factor. Factoring usually means the x method. When we see the word factor, it means we're going to do the x method. So let's go ahead and do the x method. So I'm going to put -3 up here and a -2 down here. Now I'm going to think, what are two numbers that multiply to -3 and add up to -2? Well, I've done this a very long time, so I know that one of them is -3 and the other is +1. Okay, and I can test this by saying -3 times 1 equals -3, and -3 plus 1 equals -2, so it works. Okay, now when I write my answer, I'm going to have x minus 3 times x plus 1. Okay, and now look at what my two numbers are. Look at how I got a value of -3. Let me change my color. I got a value of -3 and I got a value of +1. Well, what are my two zeros? One of the zeros is x equals 3 and the other is x equals -1. So what just happened? We just switched the signs. And this will be true for every quadratic. Once you factor it and switch the signs, then you get your zeros. So the last question says, based on what you found in letter C, determine where the zeros are algebraically. Verify using a table. Okay, and so all this, when it says algebraically, it says it wants you to show all of the places where does y equal 0 algebraically. Okay, and something interesting we can do here, and this is something called the zero product law. That's what we're going to talk about today. Let's take a number like, let's say we want to do let's say we want to multiply, and when we multiply we want to get an answer of 0. What times 3 gives me 0? 0, right? What if I want to do -2? It'd be times 0, right? Anything I want to get a 0, I have to multiply by 0 to get it. So something interesting called the zero product law, and it applies to this, is that we're looking for all of the places where y is 0. Well, y can only be 0 if one of the factors is 0. So I'm going to take my factoring, this x minus 3 and x plus 1, and I'm going to say, look, one of these has to be 0 in order to be a factor. So I'm going to say, let's pretend that this one is 0, and let's pretend that that one might be 0. Then if I simplify and I solve this for x, I end up getting x equals 3, and I subtract the 1 here, and I get x equals -1. And aren't those my two zeros that I got on the graph, x equals 3 and x equals -1? Yeah. So this, taking the factors and pretending that one of them is 0, is how we do this algebraically. So let's formalize that into something called the zero product law. It's a really, really important problem-solving technique. Okay? So the zero product law says if 2 or more quantities have a product of 0, that means 2 things multiply to 0, then at least one of them must be equal to 0. Right? If you multiply something and get 0, you have to have had multiplied one of the things by 0. You cannot multiply something and get 0 any other way, is what this law is saying. And because of this rule, we can fudge around with the algebra to figure out where our answers are in a quadratic function. Okay? So in other words, if a times b equals 0, then either the first part is 0 or the second part is 0 or both are 0. So when I did exercise 1 at the very bottom here, and look, I said that either this part is 0, and I set it equal to 0, or this part is 0. Because look, we want to get those zeros for y. So let's practice this a couple ways and showing you how the regions might present this to you guys. So here are 2 examples of 2 things to factor, or 2 quadratic functions, right? So this is saying that, look, I'm going to multiply, let's say that this first thing is a, and this second thing is b, and it equals 0. The product law says either a or b is 0. So what I'm going to do is, I'm not used to my new pen here, what I'm going to do is I'm going to take each of these things and I'm going to break them off. So here's the x minus 7, and I'm going to say, well, either x plus 7 equals 0, or the x minus 2 has to equal 0. One of these 2 things must equal 0 for my total answer to be 0. That's logic. So I've created these 2 equations, now I solve them. Subtract 7 on both sides, and I get x equals -7 for one of my zeros. And for this one, when I add 2 on both sides, I get x equals 2 for the other zeros. So these are the places, these are my x-intercepts, these are my roots, these are my zeros, once I set them both equal to 0. Okay? Let's try the second one. The second one's a little different because we've got coefficients, but the same rule applies. I'm going to take this first part, the 2x minus 1, and I'm going to set it equal to 0, or this 3x plus 4 equals 0. Now this solving takes a little bit more time because I have to do 2 steps. So I'm going to add 1 first, then I get 2x equals a positive 1, divide both sides by 2, and I get x equals 1/2. Oops, my pen stopped working for a second. It's okay if you get a fraction. That's not a big deal. It just means that your x-intercept is on the fraction. Solve the second one. Subtract 4 on both sides. 3x equals -4. Oops, I didn't mean to make a line there. Sorry. My next step is to divide both sides by 3, and I get another fraction. X equals -4/3. So I found my two zeros. Okay? So it's really important that you understand the vocabulary here. And I'm going to be clear. These two things, these are called factors when they're in the parentheses. When they're in parentheses next to each other, they are called factors. So when the problem asks you to factor, it's asking you to put them in parentheses for multiplication. If the problem is asking you to find the solutions or to find the zeros, okay, that's when you want to find the x equals. So these right here, these are your zeros or your solutions, okay, or your roots. Okay, really important to understand the difference between factors and zeros. Zeros is taking it one step past the factoring stage. And it's also really vital that you really mastered lesson 10.5 and 10.6. Okay, because factoring, you can't do this if you don't know how to factor. All right? So let's take a look at some other problems. So this is just some more practice problems. So exercise 3 says, find the roots. Like I said, roots and solutions are the same thing for saying zeros. So find the roots, find the solutions, find the zeros, all the same idea, right? These three words mean the same thing. Okay? So let's go ahead and start letter A. So letter A, I see that I'm going to have to factor this. I'm going to use the x method. So I'm going to put -12 here and a 4 down here. Two numbers that add up to -12, that multiply to -12 but add up to 4. So I'm going to write these out. 1 times 12 wouldn't work. 2 times 6, 2 times 6 would work. If I do 6 minus 2, I'm going to get a +4. Then this takes us back to lesson 10.5. So if 10.5 was something you struggled with, I suggest going back and taking a look because it's a really important lesson. Okay, now from here, I know that my factors are, another thing that's really important with notation here, and I'm going to be really clear, you must have it equal to 0 before you can do this. So I'm going to make this clear. You must have your equation equal to 0 first. Okay, see how all of these have this equal to 0 part? You can't do this process unless you have a 0 at the end of there, and that comes to play in mastery, okay, because there's some mastery problems that require you to set it equal to 0 first. Alright, so I'm going to keep with this notation, and I'm going to get x minus 2 times x plus 6 equals 0, and then I'm going to do my split where I set them both equal to 0. X minus 2 equals 0, and x plus 6 equals 0. Now I solve them both, and I get my first root or 0 or solution to be 2, and I get my second solution to be -6. Okay, so these are my solutions. I've solved this. When I plug in 2 and -6 back into here, I should get 0 for both of them. Alright, and that's one good way to check your work. Let's take letter B. Letter B is a little different because letter B, I can't use the x method because I don't have a constant at the end, but I noticed that this problem has a GCF. So I'm going to do this the GCF way. So this is 2 times x times x. This is 2 times 7 times x. So they have a 2 and an x in common. So I'm going to have 2x as my GCF, and then what's left over on top is the x. My sign is a minus, so I'm going to have a minus, and what's left over on the bottom is a 7. Now I'm going to take each of these, I'm going to put this in parentheses just so I can show you how you split them up more. Normally we have like an x minus 2 or an x plus 5, but it's okay if one of your factors is just a term. So I'm going to set that equal to 0, and I'm going to set the x minus 7 equal to 0, and I've created two things I'm going to solve. When I divide this by 2, I get one solution to be 0. That's okay. You can have a graph going through 0 as one of your roots. When I add 7 to over here, I get the other solution to be 7. So my two solutions, my two zeros for this graph is 0 and 7. You can also always check in your calculator. You can graph it and see if it works on your graph. Okay, but you remember, you have to have it equal to 0 first. Okay, letter C, I noticed something very cool about letter C. Letter C is a difference of perfect squares, which I love these because it means I don't really have to do any work. I know that a difference of perfect squares has that cool property where I take the square root of both. So I'm going to take the square root and I get x squared and 5 squared. I know that it's going to become x minus 5 times x plus 5. Okay, this is from lesson 10.4. So if you don't remember this lesson, it's from lesson 10.4 where this becomes a difference of perfect squares, and I can split it up like this. When I do that, this becomes x minus 5 equals 0, and this becomes x plus 5 equals 0, and now I solve. Add 5, add 5. My first 0 is a positive 5, and my second 0 should be the opposite at a negative 5. Okay? And finally, the last one here for this practice is going to be a x method, but it's going to be the one where you have to multiply first. There's no GCF here, so I'm going to do the x method where I multiply the 2 times the negative 12. So I have a negative 24 up here and a 5 on the bottom. I've done this so much that I can do this very quickly, and I know that it's 8 and negative 3. 8 times negative 3 is negative 24, and 8 plus negative 3 is that 5. So I know that 8 and 3 are my two factors. So when I write this out, I'm going to, oh, I forgot, when I have a coefficient greater than 1, what do I have to do next? I have to divide it by the 2. So I'm going to take this 2 and I divide each of these by 2, and I get this to be 4, and this over here just stays negative 3 over 2. So when I write my answer, my first one, this fraction, becomes 2x minus 3, because remember the 2 here goes in front as a coefficient, and the minus 3 goes next, and this just becomes x plus 4. Remember to keep my equals 0. Now, same zero product law, set each of these factors in parentheses equal to 0, and solve. I'm going to add the 3 to both sides. 3's cancel out and I get 2x equals 3. Divide both sides by 2 and I get x equals 3 over 2. Over here I'm going to subtract 4 on both sides and get x equals negative 4. Okay? So this is the zero product law, and this is finding zeros, roots, and solutions when you're just given the equation. You can always graph these things to check. Okay, but the process of, using the algebra, a lot of times the regents will say do this algebraically, and then you have to show it with algebra. Okay? Finally, this says find the zeros of the quadratic function algebraically. That's exactly what I was talking about, right? The regents will ask you to do this with just algebra, and then say verify your answer on a calculator. Okay, so the first thing I'm going to do is I'm going to rewrite this. Y equals 3x squared minus 6x minus 24. Now I can see right away that this equation has a GCF. I can see that there's a 3 in each of these. So I'm going to go ahead and find the GCF first, because I want to get that GCF out. So this is 3 times x times x. This is 2 times 3 times x. This is 2 times 2 times 2 times 3. And again, the calculator will do the factoring for you if this is a part you struggle with. I see they all have this 3 in common. Okay? So, the first thing I'm going to do is I'm going to pull that 3 out. What's left over on top is 2 x's, so that gives me x squared. My sign is a minus, so I'm going to put the minus there. Left over here is a 2 and an x, so this is minus 2x. And I have 2 times 2 times 2 times 2 here, which gives me a minus, because there's a minus here, 8. And I'm going to set this equal to 0. Originally I had a y here, but what did I say was important about the zero product law? You've got to set it equal to 0 because you're trying to find the 0. So I'm going to set that equal to 0. Alright, now I know that this here has to be done using the x method. So I'm going to draw my x, a negative 8 goes on top, and a negative 2 goes down here. What are two numbers that multiply to negative 8 and add up to negative 2? A negative 4 and a positive 2. Negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. If you want to write it out over here, just to double check your work, I think that's always a good idea. It works, so I know I solved my puzzle correctly. Now, you're going to bring this 3. Do you see this 3 down here? And this is lesson 10.6. Bring the 3 down, okay? And now put your new factors into the parentheses. So this becomes x plus 2, and this becomes x minus 4 equals 0. Okay? So now the same process as before. Take each of the factors, this x plus 2 equals 0, and the x minus 4 equals 0, and solve them. Subtract 2 on both sides, and you get the first factor to be a negative 2. This one, add 4 to both sides, and you get x equals to a positive 4. Now, I know that that means that on my graph, I'm going to have, let's draw these in a little better, 1, 2, 3, 4, and 1, 2, 3, 4. Now I know that I've got zeros where? I have 1 0 at negative 2, so I know my graph is going to go through here, and I have another 0 at, positive 4, so I know I have a point right here. So if I go to my calculator app, right? If I go to my calculator app, like I normally do here, and I go to graph, get a new graph, Control N, don't save, add graphs, and I put in what my equation is. So here's my equation. Y equals 3x squared minus 6x minus 24. So 3x squared minus 6x minus 24. And I hit enter. I get my graph. And you'll notice, look at the graph. Do you see right here where the little hand shows up that that's at negative 2? And do you see over here that that's at a 4? Okay? And the window here has a minimum maximum of 30 and negative 30. So I'm just going to change my window setting here really quickly. I'm going to make my x minimum negative 5 and my x maximum 5. My y minimum is negative 30. Oops. If I can go back. Okay, so negative 30, and my y maximum positive 30. So I'm just lining it up with my graph that the paper gives me. Hit OK, and there's my sketch of my graph. Something interesting has happened. Oh, they just split it up into the 0.5 here. So if I hit Control T, and get my table, do you see here where I have a 4? Do you see how there's a 0 here? Look how I have a 4. That's my 0, right? That is my 0. Do you also see how on the other one at negative 2? Let's scroll up. See how it's also a 0? Okay, both of these are zeros. Okay, and I've got, negative 1, negative 15 is about right here. The other point, 0, negative 24 is about right here. I have 1, negative 27, so about right here, 2, negative 24. So my curve is kind of looking, it's going to go like, let me get my graph. It's going to kind of go like this. Wait. How do I undo? Is there an undo button? Yeah, there we go. Let's try this again. So my graph is going to look like this. This is not the prettiest graph, obviously. It should look like that picture, but when they give you a grid that doesn't have the good coordinates, it's difficult. It's more like this, maybe. Okay. So there's my graph. Alright, so the key part here is to realize that when you do this algebra, you're going to get those zeros on here. So here was your first one at -2 and your other one at +4. The last thing I want to share with you, I know this video has gotten kind of long, but I really want to share with you a situation where you might have to solve for 0. So let's say you have something like x squared plus 3x equals 7 minus x. Let's say you have this, and you're trying to get this to be equal to 0. In fact, let me change this. Let me make this a x minus 5. I think that will work. Add 5, 4, no, sorry. Let's make this a 3x. Alright, this should work. Okay, so let's say you're given something like this, and right now it is not equal to 0. Okay? So what I have to do is I have to start getting all of this stuff over here, and I have to move it to the left. So you want to move everything to the left side. So I'm going to start by adding 5 over. These cancel out, and I get x squared plus 3x plus 5 equals 3x, right? These are not like terms, so I can't combine them. Okay? Let's make this a -3x. Okay? Now I'm going to add the 3x over. These cancel out, and I get x squared plus 6x plus 5 equals, when these two numbers cancel out, you get 0. Now you can go ahead and do the x method, right? Where you put 5 on top, 6 on bottom, 5 times 1 is 5, but 5 plus 1 is 6. You know, so this is really important that you set it equal to 0 first. You're going to see things like this in the mastery, so I really hope that you're paying attention right now, because the mastery is going to have problems like this. Okay? You know, I'll finish this problem where you continue to set these equal to 0, subtract on both sides, and solve. And, you know, part of this is that your fluency needs to be taken really seriously. For some of us that are getting closer to Regents, these are becoming really crucial lessons, and I see these pop up a lot. Okay, so please ask me for help if you need it. This right here is really important. So I hope you write this down somewhere on your notes, this example of moving everything to the left. And in fact, I'm going to change this where it's saying, I happen to abbreviate, so I'll say here that it's not equal to 0. Alright? Alright, this has probably been my longest video ever, so I'm going to stop and let you guys practice your fluency. Please ask for help if you need it, and good luck.